Hello again and welcome back. In this lesson, I'm going to talk to you about extraction of raster cells to new rasters, specifically using the extraction toolset in the Spatial Analyst toolbox. We'll take a look at the Extract by Mask tool in depth and also do a quick overview of the other tools in that toolset. This is where we're really going to start illustrating the divide between raster tools and vector tools. Earlier in this class, you learned about how to clip polygons, where we could take a polygon and sort of use another one as a stencil to cut off parts of the polygon and extract only the part we want. Well, we can't use the clip tool on raster data. There are fundamentally different algorithms underlying that extraction process from polygons versus rasters, so we need a whole separate tool set for raster data. This is really where the Spatial Analyst toolbox comes in. It's designed to work on raster data, and some of the tools in there are standard toolbox tools that are meant for raster data, and others are totally new raster analysis tools. The extraction tool set in particular is sort of like different versions of the clip tool, but for raster data. I want to point out three, and then we're going to go in depth into one of these. But I want to point out extract by attributes, extract by mask, and extract multi-values to points. Each of these is a really great tool. And let's open up extract multi-values to points first. If spatial join takes polygons from one feature and it attaches the attributes to another feature, and if zonal stats summarizes raster cells and aggregates them to polygons, the extract multi-values to points tool is sort of like the equivalent of that, but for points, where it takes the values of raster cells and brings them as an attribute on point features. You can add multiple rasters here that you want to extract values from, and then have it go to a point features as an attribute for each raster. It's a great tool, it's one to know about, and we're not going to go into it in more depth right now, but I want to point it out. And then the extract by attributes tool is great because it's sort of like what we did in raster calculator before, where we can basically write a quick query against the raster. But if I say Valmeyer DEM, or let's use Valmeyer slope. If I do a where clause of value greater than 10 and Valmeyer slope greater than 10 as the name, I do OK, I'll start running, and where the raster calculator only gave us back whether or not the slope was greater than 10 as a yes or no, as a 0 or 1, the extract by attributes tool gives us back the original cell values instead. So if I turn this off, I can see that I still have those cell values and I still have the gradient in the table of contents representing it. I just have null values where the condition was false. So instead of all these values being turned to ones and these others being zeros, I actually have the original data extracted as a new raster. So extract by attributes is a great way to write your own queries against your raster values and get a new raster back with the original values, instead of with the map algebra or the raster calculator having to then go do some other work and just getting the yes or no answer. Each has its place, but this is a tool to know about. The other thing about this is that unlike the clip tool, we don't need a stencil first. Our stencil is our query in this case, and that's much more flexible. We don't have to outline the areas we're interested in. Instead, we can get a new area based upon the properties of the old raster. So that's a really powerful feature. But going back to that sort of stencil approach, if I turn on the DEM again, and let's zoom back out to it, what if I want to find or pull out all the raster cells within, say, a kilometer of the boundary of Valmeyer? My first intuition might be that I'd want to use the extract by polygon tool. I have a polygon, don't I? But if I open it up, I'll see that it doesn't actually want a polygon feature class. Instead, I can provide X and Y coordinates to build a polygon that it will use to extract raster cells. That's potentially useful in another case, but not what I want. Instead, I want to extract by mask, where the polygon is itself the mask. But first, in order to get the area within a kilometer, I need to buffer my Valmeyer boundary. So we'll go to the proximity tool set, and I'll go to buffer, and I'll select my Valmeyer boundary as my input features, and I'll put in 1 and kilometer, and I'll leave the rest of this as its defaults, and go to OK. So now I have a much bigger polygon that I can use for extraction. And maybe this is my analysis area for a project, and so I want to really just clip out all my rasters and get a set of data that's definitive and smaller and portable that I can use to run all my analysis against. So that's why I want to extract this information out of my raster. So once I have that polygon, I'll go to extract by mask, and I'll select Valmeyer boundary, or I'll select Valmeyer DEM as my input raster and Valmeyer boundary buffer as my mask data, and I'll do the name of Valmeyer DEM 1 kilometer boundary, and I'll go to OK. And once again, it's running in the bottom right corner. It runs pretty quickly. And if I turn off Valmeyer DEM, or Valmeyer DEM, and leave the new one on and turn off the boundary, I can see that it extracted the data from the data set for me, and I get null values around the edges. It also sets the full extent of this to the new cells. So if I zoom to it to see what the extent is, I can see that the extent actually only goes basically just into the closest rectangle around these cells possible, but then it fills in nulls in the areas that weren't masked by my polygon. One other thing to point out is that the mask features don't have to be a polygon. So let's say I now have my slope raster that we've used before, and I also want to extract the slope raster from the slope raster in the area of the boundary buffer that we have. Now we know that I could use the same boundary buffer that I used before to extract the data from our slope raster, but just to show that it's flexible in whether we use raster or feature data as our mask, we'll use the raster that we just extracted, the 1 kilometer boundary here, as our mask data, Valmeyer DEM 1 kilometer boundary, and then for our input raster, we'll extract from the Valmeyer slope raster here, and I'll call it Valmeyer slope 1 km boundary, and I'll click OK. I'll turn off the slope, and I'll turn off the raster here, and out of that process we get the same slope raster that we had before, just within the boundary that we just clipped it using the raster that we had previously clipped out using extract by mask. We could have also used the Valmeyer slope greater than 10 to do a further clipping on our raster, or our DEM raster here, if we wanted to keep subsetting these things. So we could chain them together to do further and further extractions instead. So extract by mask is a powerful clipping tool, and you can use it in conjunction with things like extract by attributes or any of these other extraction tools in order to get exactly the raster cells you want for your analysis. That can be purely for a study area purpose, or because you need to run different analyses on different portions of your raster and you're going to divide it up into areas for different types of analysis. Okay, that's it for this time. In this lecture, I showed you how to use the extraction tools in the Spatial Analyst Toolbox to clip rasters. Specifically, we looked at the Extract by Mask tool, as well as a brief look at the Extract by Attributes and Extract Multi-Values to Points tools. These are all really useful, and I hope you enjoy them. See you next time.